Hello everyone, welcome back to another video. So today in this video we'll be looking at October-November 2020 paper 1-2. So yeah, I've been jumping around years. Like in the previous video I was in 2003 and here I'm in 2020. So I'm actually looking around all the papers and like pick some questions to try that is worth discussing, like some interesting question. And this question 38 was an interesting one, so let's discuss it. A voltmeter is connected into a circuit with the polarity shown in the diagram. So we have a circuit here, and the sliding contact is moved to NP of the potentiometer and then to NQ. What are the two readings of the voltmeter? Okay, so let's first analyze the diagram. Let's look at it. We have a very nice diagram here. Let's first analyze it. Okay, so if you're observant enough, you'll actually realize something, which is the battery. You realize the battery are not arranged in the same way. They are like opposite to each other. So no worries, we still can solve it, no problem. Don't be triggered by the battery, it's just the battery anyways. So the longer one is also known as positive terminal, then the shorter one is negative, same goes here. Okay, so let's start labeling the voltage at each point, then perhaps we can see where it leads us to. Okay, so we know current flows from positive to negative, so ideally it's going to start flowing in this direction, am I right? Okay, so that means here we will still have positive 3 volts, right? Because that is when it starts flowing and there's no resistance in between here for it to lose any volts. So it's just 3 volts, and anything in the same line of wire is also 3 volts, right? So now it's going to pass through the potentiometer, come all the way here. The potentiometer will use up all the 3 volts. Because there's only one potentiometer there. So you're going to left with 0 volts at the end. And the same thing, anything on the same line of wire, you're going to have the same voltage as well. Okay, let me repeat one more time. So first, we know that the conventional current moves from positive to negative, right? So we start in this direction. Of course, there's nothing in between here. So the 3 volts will still remain as positive 3 volts. I'll explain to you why I explicitly mentioned positive here. I could have just said 3 volts, right? Why did I say positive here? Okay, we'll get to that in a while, okay? So, positive 3 volts. And of course, you go through here, anything in the same line of wire is still positive 3 volts. Then you pass through the potentiometer, it's going to use up the 3 volts and you're going to left with nothing anymore, which is just 0 volts. So anything in the same line of wire is going to give you 0 volts as well. Okay, then go back and the current will just flow. Okay, so I want to explain about this positive 3 volts part, which I'll explain further later, but this is just like a preview for you first. Okay, so negative potential is better known as, people call it as lower potential, right? Positive is higher potential. So the negative side, which is my lower potential side, is 0 volts. And my higher potential side is 3 volts. So let's say if you put a voltmeter here to measure the potential difference, you're going to get 3 volts. Because potential difference does what? It measures the PD between 2 points. So in this case, you're going to get 3 minus 0, which is 3 volts. Always higher potential minus lower potential. Now, why is it positive? Okay, to know why is it positive, we have to go to the second circuit, which is the right hand side circuit. This one here. Okay, so I'll go in a bit detail for you. Okay, so we know at this point here is 0 volts. You do realize something, that 0 volts is at the higher potential. In this circuit, the 0 volts was at a lower potential. So, is it possible? Yes, of course it is possible. So, visualize a number line, okay? For example, you have a number line here, okay? So if let's say, so anything to the left is negative, right? Anything to the right is positive. Let me put some numbers. 1, 2, 3, -1, -2, -3, so on and so forth. Okay. So now if let's say I say 0 is the lowest value, that means 0 is at the lower potential. That means my higher potential should be something that is more positive, something that is more than 0. Right? Because I say my lower potential is 0, so my higher potential should be something that is more than 0. Now what if I say my 0, I want to set it to be as my higher potential. So what will my lower potential be? Since I set 0 as my higher potential, my lower potential should be something that's lower than 0. That means based on this number line, it has to be more negative. Therefore, at this point, it is -3 volts. So that's why I explicitly wrote here positive and I explicitly wrote here negative, so that you can see why I did that. Yeah, so it's the same concept using number line, just that now you apply it to the circuit. So back to the circuit, say the higher potential here seems to be 0 volts. So the lower one has to be something lower than 0, which in this case -3 volts. So if you were going to put a voltmeter here, okay, to measure the potential difference, you will get 3 volts as well. Because why? Potential difference measures between these 2 points, right? So it takes 0 minus -3. Why I took 0? Because now 0 is my higher potential. Always your higher potential minus your lower one. So 0 minus -3, you're going to get 3 volts. That is what your voltmeter reading would be. Okay, so yep, so that is why it's negative and why it's positive. Okay, so we have officially labeled some points in our circuit with voltage. So now let's start solving. Okay, let's go back to see what the question wants. You minimize it. What are the two readings of the voltmeter when it is at NP and NQ? So let's start with the first case of scenario, NP. Let me pick a color. Okay, there's not much of color here. Okay, I think I picked this. Okay, so first it's at NP, somewhere here. I'll zoom in for you. So that means your voltmeter is somewhere here. Right, okay, because they say they slide it to NP. So now your reading here is also 0 volts. Why? Because 3 volts has been used up by potentiometer, and at the end of the potentiometer, back to square one, back to 0. So at here, it's 0 volts, then 0 volts, go back here, then you continue the circuit, you recharge back, continue back to 3 volts. So, we want to find what is the voltmeter reading. Voltmeter takes what reading? It takes the potential difference reading. And what does potential difference does? It takes the reading between 2 points. So we have one point here, we have another point here. So if we were to calculate it, we're supposed to get 0 minus -3, which would give you 3 volts. So at NP, your voltmeter reading here would read 3 volts. Okay, so now let's look at NQ. Let me use a different color now. Okay, let's go to NQ here. Means your voltmeter should be somewhere here. So at this point, it's also 3 volts. It hasn't gone inside the potentiometer yet, so it's still 3 volts. Nothing changes. Like in this case, it has already passed through the potentiometer, therefore you stop, so you will left with 0 volts. No more already. But in this case here, it hasn't even entered yet, so of course it is still 3 volts. The volts is still the same as how it started. So if at this point is 3 volts, this point has -3 volts. What would your potential difference be then? It will be, so I say at NQ, 3 minus -3. Always higher potential minus the lower potential. And you'll get 6 volts. So at NP, the voltmeter would read 3 volts, and NQ, it is 6 volts. And your answer would be D. There you go. Yeah. So, one thing to point out is, first you need to really analyze the diagram, because one thing to be very careful of is this battery here. Yeah, you need to be really careful of your battery. You need to realize that. Okay, now, next question is, what I did first was, I actually started from this circuit. Right, I started labeling the voltage at each point starting from this particular circuit. So that's why I got 3 volts here, 3 volts, 0. So since this part here is 0, therefore the whole line of wire is supposed to be 0. Now what if, is it possible for me to start from the right hand side circuit instead? Yeah, actually it is possible, even though it seems a little weird, but it works. Okay, so now we're gonna start with this circuit and see, does it work? Okay, let's test it out. Okay, this is positive, this is negative, this is positive, negative. Of course, that doesn't change. No matter what you do, the terminal is still positive and negative as it is. So let's start from this. So current flows, of course, from positive to negative like this. So that means this will be 3 volts, right? With 3 volts. That means this 2 points should also be 3 volts. Anything the same line of wire will be 3 volts. Then as I go one round, of course I'm back to square one, the lowest potential, which is 0 volts. Right? Okay. So we've finished labeling the right hand side circuit. That's it. Because we started from the positive terminal, because conventional current moved from positive to negative. So this point here would of course be 3 volts, and anything in the same line of wire will be 3 volts as well. Then you go one complete circuit, you're back to square one to 0 volts. Okay. Now, with this information, let's figure out what is the volts at these 2 points would be. So if this is 3 volts, and it is at a lower potential, you have to have something that is higher than 3 volts at this point. Right? And that would be 6 volts. Now, why did I say 6 volts? Right? I could have said other numbers. Because if I were to put a voltmeter here and measure the voltmeter too high already. Wait. Voltmeter here and measure the potential difference, I'm supposed to get 3 volts, right? So if I take 6 minus negative 3, not negative 3, sorry, just 6 minus 3, because it's just positive 3 volts, I'm going to get 3 volts, which is my battery's value. So that is why I pick 6 volts. So if this is 6 volts, then this has to be positive 6 volts as well. So this is where it gets a little bit weird, right? Okay. If here is 6 volts, I'm going to pass through this potentiometer and I'm going to have 3 volts remaining. Which is a little bit weird because ideally it's supposed to use up the entire volts, right? But then it has 3 volts remaining. So doing this way, it's a bit weird. Your values comes out a bit weird, but it works. It works as well. Because let's test it out. Okay, we test with P first. So we put a voltmeter here. So in this case, 3 volts is the higher potential. So what you'll do is you take 3 minus 0 and you'll get 3 volts, which is your voltmeter reading at P. Right? Now if we go up to NQ, the voltmeter here, this point is still 6 volts. This point is 0 volts, higher potential minus lower potential. 6 minus 0, you still get 6 volts. It still works. It's just that the values is a bit weird. Like, I know you get it. You might be thinking, like, how come here is 3 volts? Like, ideally it's supposed to be 0, right? But since we start using this circuit, that is why the value is such. It's just, the value is just weird, but it works. So welcome to physics. you need to get used to seeing weird values like this. Yeah, but ideally it works. Of course it works. So this is just another way if you had a thought, because I had a thought of what if I started from this circuit. Will I still get the answer? Yes, I'll still get the answer. Using the same exact concept, just that different values. Yeah, still the same concept, it's just different values and different way of doing it. So you see which one you prefer. Usually by reflex, a lot of people is gonna start oops. Wait, what happened? Okay. By reflex, everyone is gonna start using from this circuit because it seems more natural to see 0 volts here instead of 3 volts. Yeah, but either way works. It's your perspective on which one you want to do it. So this question I find it interesting because of that. So I hope you learned something new here. And that's all for today's video. I'll see you in the next one. Take care and remember to stay hydrated as well. Bye bye.